Hello, my name is Yves Burkhardt. Here we stand in front of this DNE LC3 laser cutting machine. The 3 stands for a 3-meter long cutting table. Next to the machine here we have our cooling unit and the laser source. On the back side of the machine, our table change on 2 different levels. Here we have chosen a wide gap between the cutting grids, so it's very easy to unload. Of course, you could put more cutting grids inside or change the distance, that's no problem. Here, fully integrated, our electrical cabinet, so everything stays compact. Of course, the machine is equipped with a switch, so the machine can be connected to the internet. As you can see, all connections are going from the top, so we have nothing on the floor. So we want to keep the machine compact with a very small footprint. Of course, the laser source and the cooling unit could be set as well on top of the machine or on the other side. That's no problem. Let's have a look inside the machine. So here we see our aluminum cutting bridge. Here we have a gantry driving system, which means we have left and right the motor with rack and pinion to move the bridge forward and backward. For the Y-axis, we have as well a rack and pinion motor. Z-axis is with a spindle. One of the most important parts of this machine is the cutting head. As you can see, the cutting head is very slim, so we avoid collisions. Here on top, we have a protective glass. So while cutting, we're producing small splatters. They jump all around. And to avoid that those splatters go on our lens, we have here a protective glass in front. Very easy to replace, so we won't hurt our lens. So in case if something goes up, we just have to replace the protective glass. As you can see, this goes very fast and we can continue to cut. All the trash that we are producing, or the small parts that are produced while cutting, are falling down in those bins. So it's very easy to empty them, to clean them, or as well to replace or to take small parts that have been fallen down. Not to forget, our hand control is really helpful if I want to position a part somewhere in the cutting table, or if I want to do a hand cut. This is a very useful tool. One of the great features that we have on this machine is our parameter tuning. So the parameter tuning is helping you to figure out the perfect cutting parameters for an unknown material. And we start our experiment. We are generating automatically a parameter, 5 parts being cut, and then we will rate those parts accordingly. So now I got my 5 parts. All the parts are labeled, so I can figure out which part is which one, and I give them a rating accordingly. So it was the best one, second, third. The other 2 ones are not really good. So let's continue. According to this data, we are generating a second set of parameters for the next 5 parts. And again, we will rate those parts accordingly and continue. So at the end, we have just 2 parts remaining, which are the best parts of each set. And now we have to compare which one is perfect. So our parameter set is generated, being saved on the machine. Then the next time we're going to cut this material, we're going to have a perfect parameter set. So now I suggest that we cut something. So before we are cutting our parts on the machine, we have to program them offline. Let's start with importing a DXF in our DNE power cam. We'll choose the material and the thickness. Here we have the geometry of our part, which we could change as well if needed. We have the cutting technology that is missing, so we just press here on the rocket. Cutting technology is added automatically. So we'll save the file in our database. Now we need to do a new job. Here we are making our nesting. So we will add first a sheet, 3 meters by 1.5 meters. Now we'll add a few parts. First the part that we imported, then we'll add a few additional parts here. On the bottom here, I can change the number of parts. And like before, I just press on the rocket. The entire nesting is happening automatically. I have nothing to do with it. before we export our file, we are going to go to our export settings and we are going to check and activate our waste crushing, the scrap destruction here for this part, because that could cause a collision. So first, let's go to the simulator to check if everything has been done. Yes, we have added these trash cuts. So we can export the file to the machine and we are ready to cut. Now that we have done our programming, we are back on the machine and we want to cut that plan. So let me quickly give you an introduction of our HMI. Now I'm adding the job that we did just before. Here on the bottom we have a preview of the nesting, the size. Let's add this job to our job list. That's our job list. So we have all the jobs. I can of course change the cutting order. I can shift the job on the top, for instance, because we will cut this first. I can as well go and add functions, change functions, so I can add micro joints, for instance, according to measurements. I can add stops, I can add edge detection, all these kinds of functions here on the CNC. I could, for instance, as well change the nesting. So here we have nesting that has been done in the software. Here I can change the dimensions of my sheet. Let's make it a little bit longer, so we have more space. And now I can add parts from other jobs. For instance, that part that we had in the other job, I will add it now to this part here. I can make a copy. I can turn the parts around. I can add skeleton cuts like this. I could cut as well the skeleton cuts off that we don't need. We can add micro joints on the parts if we need that. So very easy to adjust your cutting plan quite fast. Now let's go to cutting. Here in the cutting part, we see our plan in different colors. So as you can see, we have different colors for certain contours. We can adjust the entire parameters while cutting. So for instance, the parameter for engraving, for piercing, for cutting can be all changed here on the machine. Now let's cut. Here we are cutting now 1 millimeter mild steel with a maximum speed of 43 meters per minute. So it is really fast. What you just saw now is the destruction of the scrap. So we are first cutting the long line into 3 small parts so we don't have any collisions. That's very, very important. And as you can see, the speed is just amazing. So now let's have a look at the parts that we just cut. So here that were those long holes that we made the scrap destruction that they don't stand up. On this bigger part here, we automatically added a micro joint that the part won't flip and cause collisions. This now is 6 millimeter stainless steel. Stainless steel will cut it with nitrogen as well. Here it's very important to have a stable process. Maximum speed on this part is 4.5 meters per minute. Of course, this part is not as hot because we cut it with nitrogen, but as you can see, we have a beautiful edge, perfect corner, nearly no burr, fantastic part. 6 millimeter aluminum, as well this part we cut it with nitrogen. Here again, really fast piercing. Process looks very, very stable and is extremely fast with 5 meters per minute. So 6 millimeter aluminum, quite a small part. This is slightly warmer than the stainless steel, but still not too hot because we cut it as well with nitrogen. As you can see, a beautiful edge, fantastic part. So next part is going to be 10 millimeter mild steel. We cut a 10 millimeter mild steel with oxygen. You can see the piercing is really, really fast and it's extremely safe, which is very important. So we cut this part with oxygen. We have here a speed of 2 meters per minute. So you will see the part has a beautiful edge. So as you can see, of course, with oxygen cut, it's quite warm. That's why I have to take a magnet. Beautiful edge, as well the sharp corners, perfect, nice small hole. So next part is 15 millimeter mild steel. Again, we're going to cut this part with oxygen. As you can see, we have a very stable piercing, very nice cut. We're cutting this part with a maximum speed of 1.3 meters per minute. Again, here it's very important that we cut the parts stable and we have a secure process. So you can see as well a little bit of smoke coming up, which means the part is getting really hot. So the thicker we cut, the more heat we are putting inside the material. So this part, of course, now is quite hot, but as you can see, a beautiful cut. It's a black cut, of course, from the oxidation, from the oxide cutting, but a beautiful part, perfect.